So we're given probability of A is 0.4, probability B is 0.7. We want to find a lower bound and upper bound for probability A intersect B. So we're going to start with probability A union B. We know that this is a probability, so by definition, probabilities have to be between 0 and 1. Now we can rewrite probability A union B as probability of A plus probability of B minus probability of A intersect B. And now we're going to replace probability A with 0.4 and probability B with 0.7. Okay, so we can add those up. We get 1.1 minus probability of A intersect B. So this right now, what we need to do is get probability of A intersect B by itself. So we're going to subtract both sides by 1.1. And then we're going to multiply by the negative. So when I multiply by negative, I'm going to flip the inequalities. So we get that probability A intersect B is greater than or equal to 0.1 and less than or equal to 1.1. Well, I'm going to ignore this for now because, I mean, that's obvious. We know that 1 is the upper bound. So that doesn't really give us any extra information. So what I'm going to get out of this is that probability of A intersect B is greater than or equal to 0.1. Okay, so that's part A. Now for part B, I want to find the other inequality. So I want to find the lower bound. Okay, or rather the upper bound. So we're going to start with, again, probability of A union B, and this is greater than or equal to probability of B. So you may be asking, why is this? Well, think about it. Here's kind of a rough proof for it. A union B is everything, right? It's all of A and all of B. Versus B is just by itself. So there's more to A union B. There's more area. Think of it as more area versus probability B. Now if A is nothing, then they're going to be the same, right? But usually, if A is not empty, then A union B is definitely greater. Okay, so that makes sense. So we're going to rewrite probability A union B with probability of A plus probability B minus the intersection. And I should also add that I chose probability of B because it's bigger than probability of A. So I could also, say that A union B, the probability of that is greater than or equal to probability of A, but I want to use the bigger value because I want to find an upper bound. So I want to find the maximum it could be. Okay. So now I have probability of B's on both sides. So I can eliminate that. And then what I'm going to be left with is probability of A greater than or equal to probability of A intersect B. Okay, so I'm going to remove the probability of B's, and then I'm going to move the probability A intersect B to the right. And we know that probability of A is 0.4. Okay. So this is the upper bound. Okay. And this completes the problem.